Okay, hi everybody. Yeah, thank you so much for coming. So today I'm going to be talking about why I think you should build your next product with AppSync. A little bit about me. My name is Marco. I was born, I'm originally from Italy, but I live here in Belfast where I've been for a few years. I'm the CTO at a small fintech startup called Trillo. And I've been a software developer and software architect for just over 12 years. I'm an AWS community builder in the serverless space. And I also write a newsletter called the Serverless Mindset. If that's the type of thing you're into, hopefully, given that you're here today, perhaps you might want to subscribe. So a little bit of what I'm going to be sort of talking about today. I'll begin with sort of briefly touching upon sort of what I call the evolution of AppSync, kind of how it started, what was the original sort of premise and promise, that the thing that it was trying to sort of deliver, and then we'll sort of explore a little bit whether it was able to deliver it fully back in the day and whether it's improved in any way over the last few years. And then I'll just proceed to give you sort of almost like in a rapid fire mode, 7 good reasons for why I think you should really consider using AppSync for your next project or product. Of course, if you are already using AppSync, then kudos to you. Maybe what I've noticed often talking to people is that even if they are using AppSync, a lot of people don't perhaps, maybe they use it because they were told to use it by somebody, but perhaps they don't fully appreciate just how powerful it is and they don't love it necessarily. It's just something that they endure it, and hopefully, if I can, I'll try and kind of spark a little bit of joy and love if you're one of those who's already using it. And again, if you aren't using it, I'm gonna try and convince you that you really should give it a go moving forward. So the evolution of AppSync. One word describes AppSync sort of early on, and it's what I call VT hell. Let me backtrack for a second. AppSync, so when AppSync was launched, this was in 2017, so obviously AppSync being a managed GraphQL engine that connects natively to AWS services, it had the following kind of building blocks. It had what is called data sources. First of all, it had the schema, which is your GraphQL definition of your queries and mutations, entities that you want to define as part of your system. Then it had your data sources, which were sort of typically, it could be third parties, but typically it would be your AWS services that you wanted to talk to in order to get the data to fulfill your schema. And then it had the resolvers, and the resolvers is where VTL comes into play. The resolvers were basically, where you could add a little bit of context around your data sources. You could say, for example, if your data source was DynamoDB, you could say, as part of the request, make it look like this, format it this way. And then as part of the response, maybe take away this field and show me just that other field, or something of that sort. A choice that was made by the AppSync team back when it was launched, which I've talked to some of the people that were behind that choice. There were good reasons, I think, in their minds. But in practice, for a lot of us kind of on the ground actually using it, it didn't turn out kind of as positive. And it was the choice of using for your resolvers this language called velocity templating language, also known as VTL. I'm sure you've all come across, like you've all seen what a templating language is, right? Typically, you have like maybe an HTML page, right? And you've got little bits and pieces of data, within, sort of embedded into that HTML. Sometimes with a templating language, you can be super adventurous and do like maybe a small if-else condition, or if you want to be extremely ambitious, you can try and do maybe a little for loop. That's as far as it goes, right? As soon as you try and do more than that within your HTML, things are going to get out of hand very quickly. And so you don't really want to use a templating language for that, and it's not really meant for that. And so that is absolutely true for VTL as well. And so it became very quickly what I've come to call VTL, as you can see. That it's not super clear on that slide. It's a little bit cut sort of on all sides, but basically that is but a small section of what is like a file that is probably 3 times as long of what one of our, I went back into one of our old repository to look at kind of what the original velocity kind of files that we used to write back in the day for these resolvers, what they look like. Long story short, that whole thing is unintelligible. Nobody, not even the person who wrote it, has any idea what that does. It's so complicated, so convoluted, it makes no sense. It was very, very hard to test even back in the day because, of course, the templating language is not meant to write complex business logic and so on. We didn't have, for example, things like even like a unit testing framework for VTL. There was no such thing. I don't even know if there is something like that these days, but there wasn't, and there shouldn't have been, obviously, because it's a templating language. So yeah, so testing your code was very hard. The language itself, as I said, was very obtuse and hard. And so that meant just the general developer experience was very, very frustrating. And so you were sort of in a place where once you got it to work and you could send it to production, AppSync itself was extremely powerful. So that was amazing. But just getting it to work exactly the way you wanted because of VTL was a real challenge. So then kind of AppSync begins to evolve. And so in, I think, 2020 or early 2021, they introduced the concept of Lambda resolvers. So now what you could do is instead of using VTL, you could point your AppSync to a Lambda, which would then, where you could then put all of your business logic. That was obviously a game changer in so many ways because Lambda is Lambda. It's just code, and so you write the code in whatever language you want. You organize it the way you want. You can keep your code clean. You can test it, unit testing, integration testing, everything you want to do. So that's brilliant. We did that. So when that was launched, we didn't waste a minute. We started rewriting a lot of our more complex VTL resolvers into just Lambdas. That was great. It radically changed our ability to even just understand our code base, but it had a problem. And it's that, of course, that Lambda has an added latency, which the original VTL resolvers didn't have because they were almost instantaneous in the way that they were executed. Lambda added latency. And then if you factor on top of that the occasional cold start, it had an impact on the overall platform. And so we had to sort of strike a balance between, okay, where there is a lot of complex logic, we are going to be using a Lambda, knowing that we're going to suffer latency a little bit, but then in other places we're going to have to just keep going with VTL in places where we want absolute performance. And so then, end of 2021, I think, JavaScript resolvers were launched. This was what we were all waiting for. This was what probably should have been done from day one. JavaScript resolvers are the exact equivalent of the velocity kind of initial templates, but in JavaScript. So now you can write these, you can write just JavaScript or even TypeScript if you want to. You can unit test it, you can do whatever you want. You can organize it as nicely and as cleanly as you want, but it's executed immediately. The latency there is no latency other than obviously the execution time that it takes, for example, for your Dynamo query or your S3 request to complete. So JavaScript resolvers have now brought, this is like 4 or 5 years into it, have now brought AppSync in a position where it's really able to deliver on what was the original kind of premise and what it promised to deliver back then. And also the other thing that has been done is that more direct connections have been added. So now AppSync was always able to connect to any service, AWS or non-AWS, via HTTP endpoints. So any service that had an HTTP endpoint, you could connect to it as a data source. But then what's been done over the last few years is that more and more AWS services have been added as a direct connection, which means there's just less hassle. Most noticeably, I think EventBridge was one of those that was added, and it's made it like super convenient. So you can have a query where you send an event, you send a request to perhaps an EventBridge rule, and because it's a direct connector, you maybe have to write 1 or 2 lines of JavaScript and it's good to go. That saves you from building a whole backend kind of around your request. So this is AppSync today. And now let me give you, if this sounds somewhat good to you, let me give you now 7 reasons why I think you should really give it a go moving forward and why it's been so beneficial for us as we've used it. So reason number 1 is rapid prototyping. I honestly, for the last little while, it's become my go-to tool. And my team, everyone I work with, everyone we always begin, no matter what we are trying to prototype, we always begin with AppSync. Why? Because think about what you need to do when you build the prototype, right? So the idea of a prototype, you want to, there is some kind of problem that you want to prove that there is a solution for, right? So it's very narrow, and there's a lot of kind of boilerplate that you don't really want to waste a lot of time on, because there's the one thing that you want to prove that that's possible, and then you'll build the rest, right, when you go beyond your prototype. And so normally for a prototype, you want some kind of UI as basic as possible so that you can interact with it. And then you want to kind of, if you're, for example, in the world of AWS, you want to perhaps find out what the AWS services are that you will need to build that prototype. And then you need to build some sort of compute layer in between that kind of handles the request. That's what probably almost any prototype looks like. With AppSync, right? You build the UI, you have to, obviously. You write your interactions in GraphQL. GraphQL, once you get the hang of it, it looks like pseudocode. It's like you don't have to connect it to anything real behind the scenes. Just write down what your access patterns are gonna look like, what your requests and what your responses are gonna look like, and what kind of your data entities are gonna look like. Figure out what the AWS services that you're gonna need are. Let's say you want to build something like you want to build a prototype that proves that it's possible to build a chatbot for your company. So what are you going to be using within the context of AWS? You'll probably start with something like Amazon Lex, but then maybe you want to say, okay, I also want to prove that if Amazon Lex fails to fulfill the intents and the slots that I give it, that perhaps I can use something like Bedrock agents maybe, or maybe both. So I want to go with Amazon Lex, then if that fails, I want to go with a Bedrock agent, and if a Bedrock agent fails, I want to go with just a generic model on Bedrock, which will respond with some kind of pleasantry trying to explain that this didn't quite work, but in a nice conversational way. So you can go and you have to go and configure the 3 services. You assign the right model to the one, you give the right data to the other, you assign the right sources to the other. But then you now have to, even just for the context of, within the context of a prototype, you still have to build a little bit of a backend of a business logic there, figuring out, requests and retrials and failures, and then the whole fallback kind of succession of events, fails the one, go to the next, fails that, goes to the next. That's quite a lot, right? And then you need to think of, where does that go? Well, that needs to go into some sort of compute layer. So maybe you spin up a quick Lambda, maybe you use something else. It's extra work. You don't need to do that. This whole last part, you don't need to do it with AppSync. So once you've got your 3 services, your Lex and agents and Bedrock generic configured, you just then attach those as data sources to AppSync, write maybe 1 or 2 lines of JavaScript in your resolvers. And again, here you don't have to worry about, for example, the AWS SDK and what the right syntax is and all that. None of that is something that you should be concerned about at this point. And then what I would normally do is run with the Amplify CLI, I run code gen, so it generates me all the code that I need to put in my UI, and I'm good to go. And I've got a prototype, a functioning prototype that does exactly what I need. And what I didn't mention also is that you have something called pipeline resolvers within AppSync. So that's why it's also really easy to have, for example, a succession of services that you can hit one after the other, because you can set up all these data sources and then set up a pipeline that says, hit the first, hit the second, hit the third, and also have conditions saying, for example, as I said earlier, if Lex fails, run Bedrock agents. But if it doesn't fail, skip the following 2 and give me the response back. So you can do all of that. And again, it's 1 or 2 lines of JavaScript super easy. So rapid prototyping, for me, I will never go back to not doing prototypes with AppSync. It saves me so much time. And what's beautiful about it is that all along, as I was doing that, I thought I was just writing a prototype. I actually now have a product, because what I just did there, that actually works, and that will scale infinitely for me. There's nothing I need to add, really, for that to be a finished product, other than maybe polishing up the UI. So with AppSync, I've got automatic scaling. It's 100% serverless, so it costs me nothing if I'm not running, but it scales with me and it grows. It's got real-time data sync. It's got baked-in IAM authentication and multi-region support. Everything you need, it's got it for you. So I thought I was just writing a prototype there. I've got a product, and it's good to go. Team collaboration. The number one typically pushback I get whenever I try and talk people into AppSync is that they don't like GraphQL. I get it. I personally quite like it. I get it. I can see why that may be the case. But here's what we've found with our team is that GraphQL has become a shared language between front end and back end. And so whereas previously with regular REST APIs, there was a very strict separation between people that were busy building the UI and people busy configuring the back end. And it was really hard to communicate with each other, kind of what is it exactly that I need and what is it that I need to provide to you as back end people, to you front end people. With GraphQL, because it looks like pseudo language, it's really easy to understand. So front-end people have become much more adventurous. They don't mind going into the GraphQL schema and updating it so that it reflects the exact properties that they need on their front end. And equally, then the backend people there's no really a lot of interaction or a lot of back and forth needed. They can just look at how the schema was updated and see, okay, these two properties have been added to the response. How are we going to provide the data for those two properties? Well, that thing has to come from Dynamo. That other thing has to come from S3, but it needs to go through a Lambda that needs to do some extra processing on top of. Okay, doesn't matter. We set it up, and then we send the response back. Nobody in front-end world has to even have the slightest idea of what that even looks like. And it can be done without, as I said, a lot of kind of back and forth. So it just reduces misunderstandings and it parallelizes work. Typically what we do is we sit down and we define the GraphQL schema before we even begin to build a new feature or even a new product. And then once everyone's more or less, it can change as you go, but once everyone's more or less clear on what the schema looks like, the backend people, the database people, and the front-end people, they can just go their separate ways and build what they need to build. Native AWS integrations is another good reasons why I think you should use it. As I've mentioned earlier, you can connect directly to a whole bunch of AWS services, and there's typically no need or very little need for any glue code. Which then in turn, what that does is, next reason, is error reduction. Because you're not writing a whole lot of custom code and glue code, and you're not spinning up all these compute layers that you don't need really. There's less reliance on this custom code. There's therefore fewer potential points of failure, and there's just less boilerplate. You can see exactly, here is a resolver, here's a data source, here's what I'm invoking. There's no boilerplate in between that kind of, it's not that you have to spend 15 minutes figuring out what it does before you actually understand what's going on in the application. Cloud native evolution. Here I'm stretching this point, okay? I'm not really trying to say that AppSync is the same as using something like Django or Ruby on Rails or Laravel. But what I'm trying to say is that, because AppSync is obviously, it's not a battery included framework like those are. But what I'm trying to say is that a lot of the conveniences that people normally would be looking for when they decide to use those frameworks, AppSync gives you that. Not all of it, as I'm saying, but like a lot of it, it does it for you. And so if you're looking for something that's almost like a centralized starting point for you, from which you can build all your logic and that you can grow out of it, from it, AppSync does it. AppSync can be your centralized place where all of your definitions go, and then you grow but what you do then, you're backed by the cloud. So whereas those frameworks, as good as they are, they tend to typically be quite, or often they can be, especially if badly configured, they can be quite heavy and difficult to scale. Of course, AppSync will scale with you. It's backed by the cloud. There's infinite scalability, as I've already mentioned. And lastly, it's empowering small teams. I know for us, we have a very small team. We were able to rebuild our entire API layer, which used to be based on API gateway, and it was massive. We were able to rebuild it virtually entirely in a few weeks with AppSync. And since doing that, it's made us much more productive. It's made us able, as I've said before, to parallelize our work. It's given us, and this is a really important thing, it's given us a lot of clarity over our data access patterns, because now we have this GraphQL schema that we can look at, and it gives us immediate clarity over our data access patterns, the types of queries that we need, and that we use, because if they're there, it means that they are used. You can have your diagrams and your architectures, and you need that, and you can have your documents where you keep track of your data access patterns. That's all very useful, but really, if you go and look, for example, at your kind of API gateway definition, it's very, very hard to understand what the data access patterns are there, what the typical, even a typical user journey looks like when you look at all the possible REST APIs that you've got available in your system. When you look at GraphQL instead, it's actually kind of easy to see, oh, these are kind of as part of that feature, oh, these are the things that the users normally request, and these are the types of things that normally we send them back. And as I've mentioned before, it's made it easier for front-end people to venture into the back-end. This one is interesting because for some reason, we've noticed that front-end people don't mind too much. As I've said, front-end people are now much more comfortable updating the GraphQL schema, and that's one thing. But we've noticed that with AppSync, they don't mind too much also going to the next step, and sometimes also going into the actual data source and setting up, for example, a DynamoDB query, because it looks super, super simple, super, super easy. They can copy paste from a previous one that was already there. It's not as intimidating, even if they're not maybe like DynamoDB experts or whatever. So overall, it's just made everyone more productive. And this is, so those three services there, multiply that by many, many, many more. But this is, at a high level, what at least a part of our system looks like at the moment, right? So we have a bunch of different front ends that they all hit, internally at least, they all hit our kind of, our AppSync setup. And then AppSync hits a whole bunch of different microservices behind the scenes that fulfill all these different requests. And this, as I said, this has given us just such conceptual clarity over kind of what our system needs to do. And whenever we need to add a new feature, it means potentially just one more of those microservices need to be added. But we know exactly what it needs to be hooked into. We know exactly how the front end is going to be talking to it, how testing is going to work. Just everything is very standardized. And so these were my 7 rapid-fire reasons why I think you should really give AppSync a go moving forward. So rapid prototyping, infinite scalability, team collaboration, native AWS integration, error reduction, cloud-native evolution, and it's empowering small team like ours to move a lot faster and to do a lot better. Thank you so much. And yeah, feel free to get in touch, and if you want to talk about it anymore, I'd love to. Thank you.